All right, so today we're going to talk about synthetic division. So we did polynomial long division last time, and today we're going to look at a way that in certain cases we can do it much faster and a lot less writing and actually a lot less places for error, and how this same algorithm or same method of doing this can be applied to do something completely different, which is substitute in values into a function. So if I've got some big, long, ugly polynomial with a bunch of terms, and I need to plug in like -2 for x, we can use this to find our answer very quickly as well, and actually a lot less chances of making sign mistakes. Okay, so this is called synthetic division, and the nice thing about it is we're just going to work with numbers. We won't see x's and things like that for the most part. The drawback is we only want to use this if our divisor, which is what we're dividing by, is a linear binomial. So that means x to the first power, and binomial means there can only be two terms. And that leading coefficient has to be a 1 in front of here. So for instance, if I had something like 2x plus 5, that is a linear binomial, but my leading coefficient is not 1. And there is a way you can technically do it with this, but it's a lot of extra steps and it's not worth it. Just do long division. Or for instance, if I have like x squared minus 5, this is not linear anymore, it's quadratic, so I could not use synthetic division. I'd have to use long division. Okay, so this can only be applied in certain places, but it's nice when we can use it. Okay, so we're going to follow these steps and do an example kind of at the same time so they make sense. So our first step says find the 0 of the divisor and place in the top left box. Okay, so the divisor is what we're dividing by. This is my divisor. And we want to find its 0. So if I were to take my divisor and set it equal to 0 to find what value of x makes it 0. And you guys probably did this quickly with those quadratics before. You kind of know it's the opposite sign, but -6 is my 0. And so our setup when we do this is we're going to put kind of a box. I like to do just like a little half box in the top left, and that 0 goes in our top left box. Okay, then we're going to have this bar, a little bit of space underneath. There's going to be some numbers that go in this line and some numbers next to that number in the box. Okay, so here's a little bit of our setup. Starting with the leading term, write the coefficients of the dividend. Okay, so up top is my dividend. It's my dividend way up here at the top. So here's my dividend. So my leading term is x squared, and I like to, at least for a while when I first start these, kind of write some labels above it. I got x to the 0, x to the first, or sorry, x to the second, x to the first, and then x to the 0, or our constant, whatever way you want to describe that last one. Okay, so we're going to write down our coefficients. My coefficient of x squared is 1, x squared. My coefficient of x to the first is 10. And my constant, or x to the 0, is positive 24. So they were all positive this time. At the end here it says use 0 for any missing terms all the way down to the constant. So if we had an x squared term and a constant but no x to the first, we would just plug in a 0. And that's important that we have a placeholder for everything from our highest degree all the way to the constant. Okay, so here's our setup. I'm going to put a little plus sign here because eventually we are going to add the numbers above our line. Okay, so the first step to get us going here is we drop the first coefficient down below the line. So we drop down our 1. Step 4 says we're going to multiply any number below the line, so in this case our 1, by the number in the box, -6. We're going to do 1 times -6. Place the result above the line, but below the next coefficient. So my result's going to go here. So I'm going to take this 1 and multiply it by -6. So I'm just going to notate this our first couple times. So times -6. And that gives me -6. Okay, so we multiplied our number below the line with the number in the box, which gave us -6. And then it's asking us to add. So that's what our addition sign was here for. We're going to add these two together, which gives us positive 4. and repeat steps 4 and 5 until we're done. Okay, so any number that comes below the line, we multiply by the number in the box. So 4 times -6 times -6 gives me -24. And when we add, the two numbers above the line, we end up getting 0. Okay, so the very last term here is our remainder. So this ends up telling me that there's no remainder when I divide these two things. And in fact, you might recognize this problem. This was the first problem in the notes from yesterday, or last class. So this is my remainder. This is my constant. This would be x to the first. And if there were more terms, it would be x to the second, x to the third, as I keep going left. But in this case, I end up with 1 x to the first, or x to the first, and positive 4 for my constant, with no remainder. And so there's my answer. It's a little bit cleaner. It's a faster way to come up with our answers. We do have to derive it a little bit. This last number is always the remainder. So a nice remainder of 0 told us it went in perfectly. And then next to it's my constant, x to the first. And if there were more terms down here, x to the second, x to the third, etc. Okay, so let's check this out again. Let's do a couple more examples. We're going to follow those steps. So the first thing I need is the 0 of my divisor. So if I set this equal to 0, we're going to end up needing -2 is what's going to go in my box. Okay, so -2 is the 0 of my divisor. That's what goes in the box. And it looks like my highest degree is x squared. So I want to make sure I have something for x squared, x to the first, and x to the 0, also known as the constant. Okay, and my coefficients here are 1, +10, and +24. So you notice this is the same dividend, different divisor though. Okay, so we'll draw on our bar. Remember to leave a little space in between because we'll have some numbers up here. And to get us started, the first thing we do is drop the first coefficient down. Any number that comes below the line, we multiply by the number in the box. So 1 times -2 is -2. And we place that result below the next number. So we add these together. That gives me +8. Multiply that by the number in the box. 8 times -2 is -16. When we add these together, I get +8 again. Forgot to put my arrow there. These arrows aren't really necessary. It's just to remind you what was going on. Remember that this last one tells me my remainder. Okay, so my remainder was 8. +8 also happened to be my constant, and 1 was my coefficient of x to the first. So interpreting my answer here, I get 1 x to the first plus 8, but we have a remainder. And if you remember when we talked about writing these, when there's a remainder, it's the quotient, which was x plus 8, plus the remainder over the divisor. So we're going to write this as plus my remainder, 8, over our divisor, and this was our divisor, x plus 2. And so this one happened to have a remainder, and that's how we would interpret our final answer there. So quotient, x plus 8, plus the remainder, +8, over our divisor, x plus 2. Okay, so let's look at another one. And these are the ones that are typically will throw some students off. You guys might see why if you're looking at it right now. But first, let's start with our 0 of my divisor. And again, since it's the same as above, of course it's going to be the same 0. We're going to get -2 is what goes in the box. Okay, so there just happens to be another -2 in our box. But if you notice now, if I look at my coefficients, my leading term is x cubed. So that means I need to make sure I have something for x cubed, x squared, x to the first, all the way down to x to the 0, or the constant. So when I go to write in these numbers, x cubed is 1. It's my coefficient. There is no x squared. And that's where students will forget, I need that 0 as a placeholder. There are 0 x squareds. X to the first is +5. And my constant or x to the 0 term is negative 18. Okay, so we're next. Remember, to get us starting, we're going to drop down our first term. Don't want to forget my addition sign over here. And multiply any number below the line by the number in the box. So 1 times negative 2 is negative 2, and then we add. 0 plus negative 2 is negative 2, and then multiply. Negative 2 times the negative 2 in the box makes positive 4. We add, we get 9. 9 times the negative 2 in the box is negative 18. And when I add, I end up getting negative 36. That looked very close, like maybe we wouldn't get a remainder, but we did end up with a remainder. So remember, that's my remainder. 9 is my constant. Negative 2 is x to the first. And that 1 ends up being x squared. So I'd write this, my quotient is 1x squared minus 2x to the first plus 9. And since we have a remainder of negative 36, you could write this in one of two ways. You could write plus negative 36, the remainder, over the divisor, x plus 2. Or you could write this as minus 36 over x plus 2. Either way is okay. Sometimes when you're checking an answer key, it might say minus 36 instead of plus negative 36, but they mean the same thing. All right, let's do one more. Almost done with these examples, and then we'll show you the other way that we can use this algorithm that's pretty helpful. Okay, so we're going to find our 0 really fast. When I set that equal to 0, we're going to get positive 5, adding 5 to both sides. So positive 5 goes in my box. We do have, again, x to the third, x to the second, x to the first, and x to the 0, or my constant. Okay, my coefficients are 2, negative 13, 20, and negative 25. And we start by dropping down our first coefficient. So 1 times 5, 1 times the number in the box gives me 5. When I add, we end up with negative 8. Negative 8 times 5 is negative 40. When I add, I get negative 20. And negative 20 times 5 is negative 100. And when I add, I get negative 125. Oh my gosh. I hope some of you were screaming. I dropped down my 2 and I made it a 1 for no reason. I do remember that this was supposed to have a nice answer. Sorry about that. Let's go back and fix it. 2 was my first coefficient. 2 times 5 is 10. When I add, I get negative 3. Negative 3 times 5 is negative 15. When I add, I get 5. And 5 times 5 is 25, which does end up giving me a nice remainder of 0. So I knew this was supposed to have a nice remainder, so it's a good thing we caught me. That's my remainder, that's my constant, that's x to the first, and that's x squared. So I'd write this as 2x squared minus 3x to the first plus 5 with no remainder, so I don't even need to write it. But what that does mean is it means this, 2x squared minus 3x plus 5, is a factor of my original polynomial, and so is x minus 5. It went in nicely with no remainder, so if I multiply these two things together, these are factors of that big polynomial. All right, perfect. Next up, I'm going to show you how to use this with substitution. So this is the second kind of dual purpose that those steps can help us with. So let's say I give you this polynomial, negative 3x squared minus 5x minus 7, and I want you to evaluate that for f of negative 4. So most of you guys know we're just going to plug in negative 4 for x, and I'm going to do that onto the side here just to show you that we can perfectly well do it this way and get the right answer. Negative 4 squared minus 5 times negative 4 minus 7. Order of operations, I do my exponent first. Negative 4 times itself twice is positive 16. Come back and multiply. Negative 3 times 16 is negative 48. Negative 5 times negative 4 is positive 20. Add and subtract from left to right. Negative 48 and positive 20 is negative 28. And minus 7 more is negative 35. So there's my answer. When I plug in negative 4 for x, I get negative 35 for y, meaning negative 4, negative 35 is a point on that graph. Okay, perfect. And we can do this manually. There's nothing wrong with this way for this problem. But when you do get bigger polynomials like this, there's a lot more areas for sign mistakes, the more calculations there are. So let me show you how we can get the same answer with synthetic substitution and something called the remainder theorem. Okay, so if I want to plug in negative 4 into my function, we treat this like it's the 0 of our divisor. So it's actually just the negative 4 is going to go in my box. I don't need to change its sign when I'm using substitution. Okay, so I still want to mark things for all of my terms from x squared on down, x squared, x to the first, and x to the 0 are my constant. Sorry, this is pretty not straight here. Oh, let's fix it. All right, slightly better. Okay, so my coefficients are negative 3, negative 5, and negative 7. So we'll drop down our first one, negative 3 times the number in the box, negative 4 makes positive 12. When I add these, we end up with positive 7. 7 times the number in the box, negative 4, is negative 28. When I add those together, I get negative 35. So if you remember, when we were dividing, this was my remainder. And something called the remainder theorem says if I use this algorithm, the remainder is the output of my function at that x value. So basically, if I plug in negative 4, my remainder tells me the output, which is negative 35. So we get the same answer. We just have to interpret it a little different from when we're dividing. But the remainder tells me the answer. When I plug in negative 4, the answer is negative 35. Okay, so let's use one where we'll see why it's a little bit nicer. So there's a lot of places where I'd have to plug in manually here. So let's go straight to synthetic. We're going to put the negative 2 we desire to plug in. So they just used a slightly different setup. Evaluate this when x is negative 2, but we're plugging in negative 2. And I need something for x cubed, x squared, x to the first, and x to the 0, or my constant. Okay, so my coefficients are 4, negative 2, negative 5, and positive 6. So we drop down our 4. 4 times negative 2 is negative 8. When I add, I get negative 10. Negative 10 times negative 2 is positive 20. When I add, I get 15. And 15 times negative 2 is negative 30. When I add, I end up with negative 24. And that remainder tells me the output of my function. So that's my answer. Negative 2, when I plug in negative 2 for x, I get negative 24 back for y. Or in this case, if it was just asking me to answer, the answer is just negative 24. Okay, but that is a point on the graph. If you want to, I'll show you really fast manually plugging in negative 2 everywhere. It's a lot of sign mistakes that can happen. Negative 2 squared minus 5 times negative 2 plus 6. Negative 2 times itself 3 times is negative 8. So that's one place you could make a mistake pretty easily. Negative 2 when I squared is positive 4. Okay, so there's 2 exponents I had to evaluate. Now I can multiply. 4 times negative 8 is negative 32. Negative 2 times 4 is negative 8. Negative 5 times negative 2 is positive 10 plus 6. Negative 32 minus 8 more is negative 40. Negative 40 and positive 10 is negative 30. And negative 30 plus 6 is negative 24. So we'll get the same answer either way. It's a little bit faster and actually less calculations, less places to make mistakes with synthetic. So it's nice that this serves dual purpose. If I want to plug in a number, that's the number that goes directly in the box. When I need to divide, the 0 of my divisor is the number that goes in the box. And of course, we just interpret that answer just a tiny bit differently.